Let's now discuss composition. And diagrammatically, you can notice that the only difference is now for the diamond shape, it is still pointing to the container. Like a directory contains many containees, like files, and the same interpretation as before. A directory contains multiple file objects as their files. The same interpretation. However, you should notice that the way we draw the composition will be a solid diamond shape. So that means the containees are exclusively owned by their parents. In this case, the directory. Okay, that's something you want to notice. And when we implement the composition, no sharing should be allowed. So that'll be the principle to follow. And yeah, exactly the requirements I just talked about. There'll be no sharing among files within the directories. And we're going to assume that any code I present over here will be private attributes and also public accessors. Sometimes I don't include them in the slides or on my notes just because I don't have the space. But when you develop the code, you should still follow the same principle. Let's now go over some symbol classes, and then we'll do several illustrations. Let's say we have a file class, which is characterized by the name of the file. And then the constructor will simply assign the attribute to be the string name. And notice that here, the equal sign over here, let me give you a little bit hints for later. What we're doing here is to copy the reference of the parameter into the attribute name over here. So we're doing a reference copy, right? But this may not be acceptable by composition in general. We'll see why. And we got another class called directory over here. We got a name. And also we got an array of files, so we're instantiating the programming pattern that we are familiar with. And we got directory, which will simply got a reference copy, just copying the reference of the parameter name into the attribute name. And also we are initializing the files over here. Let's say a magic number, just initial size will be 100. Maximum 100 files that can exist in a directory, just for illustration. And we got the F file over here. So that'll be adding a file into that. So the way to do it is, first of all, we create a file objects with the corresponding file name is specified in the parameter. And then we'll simply assign that to the corresponding position. Right? Of course, here you can say this.nof if you wish, but it's not necessary. Alright, let's now take a look at the first test, which is very simple. Just demonstrate how we can manipulate the objects of directory and also files. So this is similar to the earlier illustration I did on my desktop. It's been deleted, but you can refer to the earlier video if you want to review that example. Okay, that's the test I want to go over, and this is the conceptually that's the reality I would like to mimic in the OOP over here. Let's now take a look at the test together. So we have directory and also we got file. Let me just emphasize the point I just mentioned to you. It's really important. So you can see this equal sign over here is really important to note. This is only copying the reference. This part here is only copy the reference of parameter name. Right? You can see the name is a parameter and we're only copying its reference. And this is in general not acceptable for composition, as we'll see, because that will allow the possibility of sharing because you're copying only the address, which will create aliases. Let's now go over the test case one by one. And we go, let's say the first one, we are simply creating a directory, D1, and then with the name D. Okay, so that's what has been done over here. So you can see we have directory, and then it's going to have the name simply D, and also you got the files array, which will go from 0 until 99, right? That's a magic number. Every one of them will just be null to begin with, and also the address of the object will be stored in D1, right? Just to save time, I already drew the diagram beforehand. Let's now try to add the files. D1, D1, D1. You can see the context object is simply just D1. So we are modifying D1. And add file F1.txt, F2.txt, and also F3.txt. Let's look at the first one, step into it to see. So add file over here. For the first time, the file name over here is going to be, remember call by value. File name is going to be assigned to F1.txt string, right? So that's a call by value that we learned. We actually exercised for many times already. And we simply are creating a file over here file name. Okay, so that one, so that means we're simply going to get file objects over here, and then that one's going to be f1.txt, right? And we're going to assign that to the position NOF. At the moment, NOF will be 0 to start with, right? Initially, there's no file. And then, so that means index 0 is going to point to wherever this new file objects with the file name, which is f1.txt will be pointing to. That's number 1. And following the same logic, let's say number 2, f2.txt, right? So that means f2.txt, and then we create a new objects. Actually, from the previous one, of course, don't forget, we need to increment the value of NOF from 0 to 1. Let's now do the second one. And then the second one is going to be f2.txt. So this is the file that we created, and then index 1 is actually going to point to there. And then it's going to increment the value from 1 to 2. All right, let's now finish the last one. And also f3.txt, that should be stored at index 2, right? So f2.txt. So that we also create a new file objects, and then so that's going to be f3.txt, right? And then index 2 will point to this particular file. And now I want to have I have a question for you. If you look at these 3 file objects that we have created, let me select them over here. Are there multiple aliases for each of the objects over here? That's the question. Are there more than one, multiple aliases for each file objects? Well, let's look at this one for example. For this file object, you can see only d1.files at index 0 is pointing to there. Only one, not more than one. Similarly, for this file object over here, it's exclusively owned by index 1 of the files attributes of d1. Similarly for index 2 as well. So the answer is no. Okay, so that means no sharing of files. As far as we have reached, so there's no sharing. And you can also do some insertion over here. Let's see here. Let me use green. So if you say d1.files at index 0, right? We talk about dot notation. d1.files, and then you go for the indexing notation over here. Go for the indexing. Go to the beginning of the array. Index 0 over here, and then dot name over here, and then dot equals f1.txt, right? That's how you use a dot notation. I just want to remind you. Okay, so the reason that this will be towards the direction of composition is because we simply have no sharing of the files. That's so important. So this will be the requirements for composition. No sharing. But no sharing doesn't really mean you cannot use a dot notation. Dot notation is very neutral. For either aggregation or composition, you can always use the dot notation as long as you have the links available for you to navigate. Okay, let me just say we are moving towards. Okay, so far it's a composition, no sharing. Okay, so that's the first test I want to show to you. Let's now go back and then move on to the next slides. Okay, something about owned exclusively, something I just mentioned for each one of them. And that's the object diagram I just drew on the iPad, so that's something you can also refer to. And notice the dot notation I also try to annotate on the diagram. You can look at both. Okay, second example. We want to talk about idea of a copy constructor. So the name sounds a little bit fancy. Think about copy constructor is simply just a constructor, but its purpose is actually to copy attributes from another object of the same type. So that's the definition for copy constructor. So let's read it. A copy constructor is simply a constructor which initializes attributes from the argument objects other. You can see other over here, and it's definitely a constructor. There should be a public. I just didn't have space. Okay, directory under the directory class we got public directory constructor, And the argument here is simply just another object, specifically is of the same type as the current class. So that's what's so special about copy constructor. You try to initialize an object from another object of the same type. Okay, so the same type here is really the highlights. Now our question is, how do we implement it to say, now we want to make a directory copy. If I already got one directory, let's say D1 on my desktop, I simply want to copy that and paste it somewhere else. So that's like a copy, right? You can think about that analogy. Okay, and the hints will be, the implementation should be consistent with the effects of copying and pasting a directory, which I just said, right? Think about how you will write the simple code over here, and think about what attributes you want to initialize when you create a directory objects. Give you a little bit hints here. You can see for the directory class over here, and also for its runtime objects, you should really initialize the name and also the files and also NOF. So these are the things we want to initialize. All right, so you can pause the video and think about how you can fill in the blanks for this copy constructor, given that you know about the definition and the principle for copy constructor. Okay, pause the video and think about it. Assuming that you thought about it, let's now look at one possibility for copy constructor. So I want to give you two versions of the copy constructor. The first version here is called so-called a shallow copy. So shallow copy has the following principle. Whenever you want to copy an attribute, you want to use the assignment operator. And in the case of primitive value, you're going to copy the value, of course. And in the case of reference value, you're going to copy just the address, meaning that you're creating some alias for sharing, right? So that's what I mean by shallow copy. Whenever you're using simply the equal sign and then simply directly copy either the address or the primitive value for other objects attributes or return value from the accessor, in that case, you will be considered as a shallow copy. Okay, let's now go over the code. So we got directory here. Okay, let me just go over to iPad to show to you the copy constructor, and then we'll see some JUnit test. Okay, over here. This is the test I would like to go over in just a moment. Let's now take a look at the directory class over here. So we got directory and name and also files and NOF. So these are the three attributes we want to initialize, right? Let's see what we're doing over here. Here we are saying NOF is assigned to other than NOF. Of course, you can put this if you wish. This dot and also this dot name will be other than name, and also this dot files will also be other than files. And notice that here we got three instances of the equal sign, which means we're only copying the addresses. So that's really important to actually know them over here. 1, 2, and also 3, right? Only copying addresses without creating new objects. For example, we are not creating a new object of type array. We're simply creating an alias to it. Well, I'll visualize that to show you. Without creating new objects. And more specifically, when we say only copying addresses, so effectively we are creating aliases. Aliases which allows sharing. Right? So that's about the simple definition for copy constructor in the case of shallow copy. Right? We're only copying the addresses. And let's now take a look at the JUnit test, and then we'll see. So what we have is, let's now go over line by line. First line, we're still creating D1 of name D, right? So D1 over here, name D, directory, right? That's not line number 1. And we're adding F1, F2, F3, right? That's something we did as before, right? That one should be easy. So we simply got D1 and also D2 and also D3, right? These are the exercises we did earlier, right? I don't need to trace it again. And here is the important thing. We are creating another directory D2, right? And then the way we initialize D2, notice what we are doing here. So D2 is actually taking for its constructor as arguments D1. You can see D1 over here is the arguments. Well, of course, you can also review call by value, right? But it's now for D1. And now, how do we execute this? That's also very important to really trace. So D1 over here, you can see D1 is here. Because of call by value, so I would suggest we actually do a little bit of review of call by value quickly. So now if you try to, let me use green. So this is the argument D1, and then call by value. Okay, so that means this is other, right? So call by value is actually going to do what assignments? Is behind the scene, is it going to say other is assigned to D1 or D1 is assigned to other? It should be the former, right? Call by value is going to make sure we do other is assigned to D1, right? So don't forget about this. I can see that's why I covered call by value in the very beginning of this week's module. Effectively, it's going to say we got other. Okay, so other is actually going to point to wherever D1 is pointing to, right? So other will point to wherever D1 is pointing to, right? Other is actually the parameter, and D1 over here is the arguments for the copy constructor, right? Yeah, just clarify that. And when we execute this line by line, let's see what's going to happen. So line number one, line number one is here, right? Line number one. So this will be replaced by, what's the context object? It will be the D2 that we are talking about. So this will just be replaced by D2, and also D2 over here. Okay, so D2.NOF will be other.NOF. So D2, do we have D2 just yet? Okay, I can create that. Okay, actually I already did over here. So D2, right? So this is the object D2. Let me just use a laser pointer. D2. Okay, so what I will do is I'm going to say D2 is actually pointing to this new directory objects. And the way we create that is by saying D2.NOF. D2.NOF will be assigned to other.NOF. So other is pointing to here. .NOF is going to be 3. So that's what we're doing. So that'll be 3. Similarly, when we say D2.name is assigned to other.name. So D2.name is over here. It's going to be a string reference. It's going to be assigned to other.name. Other.name is referring to this string object over here, right? We are not creating a new string object, meaning that we're going to have the following. Okay, so that means name over here is going to point to wherever this name is pointing to. So we got aliases, right? It's the two links pointing to the same string objects. Similarly, if you try to look at the last one, okay, files is assigned to other.files. Okay, well, D2.files, of course, that's the context objects. So D2, let's look at D2.files over here, right? D2.files is going to copy the address of other, the parameter other.files, which is really pointing to this particular array. So that means we're going to draw like this. So it is going to point to wherever the beginning of the array this is, right? So now if you try to do some assertion accordingly, let's see what's going to happen. So you're going to have, let's say D1.files, D2.files, right? I'll take a look. D1 is over here. D1.files is referring to this particular array over here, right? And then if you say D2.files, and then we say D2.files is also referring to this particular array. So that's why equals should be true. Right? Let's now try to see what aliasing can actually allow us to do, which is not acceptable by composition. If I say D2.files at index 0, okay, D2.files, which points to this array over here, and then at index 0, and then we say dot. So that will follow the link and go to this file over here. And change the name of this file to be F11. Okay, modify this to be F11. Okay, we're using the link. So as soon as we are doing this, that means we're not really doing composition, because the sharing will actually allow you to actually modify this particular file that's actually shared by different parties. In this case, you can see it's being shared by both this and also this. This is sharing. Right? Let me just illustrate one more point over here. So you can see this part over here and also this part over here. That's the sharing. The same files array shared by D1 and D2. So that's why if you try to modify the name from D2, it's going to be effective on D1. So that's why here I'm using D1, right? So D1, the file 0, this part over here and this part over here, these two are actually aliases of each other, right? So these two. D2, the files, and also D1, the files. Of course, just the files itself will be identical, not let alone if you just go to a particular index. And notice that how the test case has been set up. If you see here, we're trying to assert false, right? So now D1, the files at index 0. So D1 files index 0 is referring to this shared object somehow, but it's been modified to F11. It's no longer F1.txt, like how it was initially set up. So that's why this is really important to see that it's assert false. So that's why it will pass. Okay, it's really important to notice that trick. Well, not really trick, just to really specify exactly what we expect to see. Okay, so you can see no longer F1 because it's been modified through through D2. Okay. No longer the case is no longer F1, it's no longer the case because modify via D2 over here. That was a context object, right? You can see we try to modify this particular name through D2. And all the way you can see D2 dot files, and then we go to index 0, go to this file. We modify that to F11. So that would be also visible to D1.files and then at index 0, right? So that's why it's no longer F1. So that's the purpose for this particular test case. Okay, and you might be wondering what this is. So this part here, it just tells you that since we got sharing, so that's why it will violate the principle of composition. Okay, so that's why. All right, so that's about the first example. And let's now move on to take a look at another flavor of the copy constructor using the so-called deep copy.